Hi, in this video I'm going to analyze this function graphically. This is tangent x function, okay? Equal to sine x over cosine x. Cosine x has to be different than 0, okay? We cannot put the 0 in the denominator. So if you want to solve this equation, cosine x equal to 0, okay? Cosine x equal to 0 is a problem in this case for the tangent because you cannot put the 0 in the denominator, okay? Because the denominator cannot be 0, okay? So cosine x equal to 0. That means x, if you are going to solve this equation, x equal to pi over 2 plus k pi, okay? If I'm going to unit circle here, so we have 0, pi over 2, pi, okay, this is pi, this is pi, this is 3 pi over 2, okay? Let's put k equal to, let's put k, this is k is integer. If k equal to 0, we'll have x equal to pi over 2, okay? Which is not allowed to put it. So if you go to the unit circle, you will see if you put k equal to 0, that means x equal to pi over 2, which is restricted point. You cannot put cosine x equal to 0, okay? Let's put k equal to minus 1. You will have x equal to pi over 2 minus pi equal minus pi over 2, which is this one. So cosine of this point, cosine of minus pi over 2, which is 0, okay? Whatever k is, you have to put this expression. So now for the tangent of this one, for x is a real number with x is different than pi over 2 plus k pi is an integer, okay? I'm going to calculate the derivative function of this function. As you see here, this function is continue and this function is continue on this interval, okay? So I'm going to calculate f prime of x, okay? So this tangent, I'm going to take x, this interval, so minus infinity minus pi over 2 pi over 2 plus infinity, okay? So f prime of x equal to 1 plus tangent square x. This is positive function. Calculate the limit of tangent x at the point x minus pi over 2 from the right hand side of this interval, okay? It will equal to the limit of sine x over cosine x. X is approaching to minus pi over 2 from the right hand side. As you see here, I'm going to plug the minus pi over 2 into the sine. You will have minus pi over 2 over cosine minus pi over 2. Remember, always from right hand side. Sine of minus pi over 2 equal to minus 1 because it's odd function. Cosine of minus pi over 2 it will become cosine pi over 2 because it is even function, but is approaching to the pi over 2 from the right hand side, which you will have this is minus 1 over 0 plus. You will have, for example, is not, you will have a 0.00001, for example. This one is going to minus infinity, okay? Minus infinity. So I will have minus infinity here. I'm going to calculate the limit of tangent x at the point pi over 2 from the left hand side, okay? So equal to limit of sine x over cosine x when x is approaching to pi over 2 from the left hand side. Very be careful when we calculate the limit here. So you will have the, if you plug you will have sine pi over 2 from the left hand side, okay? Cosine, you will have pi over 2 from the from the left hand side, okay? In this case, sine pi over 2 equal to 1. It's finite value, okay? But the cosine pi over 2 equal to 0. But this 0 is not going to be positive, it's going to be negative. It's going to have inside 0 minus, for example, right? You will have a negative, very small negative number. But cosine x is an even function. Even function of the negative numbers always a positive, because even function. Because since we have cosine x is an even function, so that's mean cosine of minus x equal to cosine x. So you don't have to worry about a minus or plus. So you will have 0 plus. 0 minus becomes 0 plus. You will have plus infinity. So plus infinity. Okay. Input of the 0 for this function always equal to 0. What do you think about this function? This function is negative on this interval, minus pi over 2, 0, and positive from 0 to pi over 2. So this function, tangent x, is negative. So this function x, tangent x, is superior or equal to 0 when x is from this interval, from 0 to pi over 2. So tangent x is negative, x is from this interval, minus pi over 2, 0, okay? So now I'm going to put this one in the graph, okay? So as you see here, the variation table shows the function tangent x is increasing, okay? Is increasing function from minus pi over 2 to pi over 2, okay, in this interval. But this function it will be negative on this interval from minus pi over 2 and 0, and it will be positive from 0 to pi over 2, okay? I'm going to put this function in the graph on this interval to see what is the function is. So now this function, as you see it here, is starting from minus pi over 2, is an increasing function, is giving us minus infinity. So the function is coming from this way, okay, and going crossing the origin O at the point 0, 0, and keep going up this way, okay? As you see here, this function is an odd function because it's symmetry to the origin. You see this area for you see this area is symmetry. You see this area from 0 to pi over 2 equal to this area from minus pi over 2 to 0, okay? To see this function is symmetry to the origin, as you see it here. Whatever happens on the right side of this interval from 0 to pi over 2 will be the same from the minus pi over 2 to 0, but the function is negative from minus pi over 2 to 0 and from 0 to pi over 2. Since this function is a periodic function, so whatever happened from minus pi over 2 to pi over 2, it will be happen again to other intervals. It will be the same. So this function keep repeating in the same way. So at the point 3 pi over 2, you will have another asymptote, as you see here. This is asymptote of this function because this function is going towards this asymptote, okay? So this one minus pi over 2 as a vertical axis equal x equal to minus pi over 2 and x equal to pi over 2 are asymptotes of this function, okay? The same thing at the point 3 pi over 2 and minus 3 pi over 2, okay? Because this function is periodic function, okay? So I have done with this problem. This is a good place where I can stop. Thank you for watching. I will see you in next video. Bye.